Hi, I'm Alex from the marketing team at Spot. Thanks for joining us for the first session in our CloudOps Live webinar series, Mastering Cloud Cost Optimization. We're very excited to be joined by Yair Green, CTO of GlobalDots and co-author of Mastering AWS Cost Optimization.
All right. Hi, everyone. I'm Yair. I'm currently working for GlobalDots. I'm here for 1.5 years. And before that, I worked at Matomi Media Group, Fiverr.com, and Telmap, where I led the technology for many years. I'm the co-author of the book Mastering AWS Cost Optimization, together with my co-author, Eli Mansour. GlobalDots is a value-added integrator with unique expertise in the field of cloud management, performance, cost optimization, and security. Our broad portfolio, ranging from managed hosting to edge services, system integration to cloud optimizations, and everything in between. We are masters in emerging technologies and actively seeking the best new solutions prior to full market exposure. And we are also providing services to small, mid, and large enterprises across all verticals. Today, we are going to discuss the following. We'll start with a few words about COVID-19. We'll discuss the COW methodology for cost optimization. Then we'll start with the how-to part, some real-world examples of cost optimization. We'll discuss this in two different layers, one for the infrastructure layer and one from the application perspective. Then we'll go to the journey part, the steps required for an optimized cloud, and then you can we will answer some questions that people will ask. During uncertain times like the COVID-19 crisis, organizations undertake ad hoc cost cutting. To anticipate and manage such uncertainty, companies must plan cost optimization measures that will drive short-term efficiency and effectiveness while sustaining long-term growth. Every organization uses a variety of leading indicators of performance to provide a comprehensive understanding of trends applicable to their business and signal impending risk. However, only those organizations that efficiently use these indicators to make informed business decisions will continue to grow during an economic slowdown or pandemic like we now have. We can see in the graph that 86% of the companies are being affected by the current crisis. And therefore, we'll start discussing on the best ways of how to optimize your cloud workload. We'll start with the methodology that we follow when we do projects with customers to optimize their cloud. So K stands for knowledge. The first step in optimizing the cost of a cloud service is to understand the service's components and pricing model. It is also important to understand alternative services that might be more cost effective for the use case. Then architecture the A stands for architecture. At the end of the day, we have the cloud architects who guide us on how to configure and deploy our cloud environment, right? Including which services to use, in which regions, how to configure a secure network, how each component interacts with each other, and other stuff, architectural stuff. Therefore, it's crucial to architect and configure the infrastructure with cost optimization in mind. This is the process of leveraging the knowledge required earlier and use it to build cost-effective architecture. O stands for operation. the responsibility for operating a cloud infrastructure is usually distributed between different people in the organization. It could be the cloud users, it could be the DevOps engineers, the IT team, the developers, business analysts, the finance team, etc., etc. Many people that are involved in the cloud operation, and it requires monitoring, tracking of the cloud usage and cost to understand the usage patterns and to come up with ideas for further optimization. Without continuous operational tasks, the cost optimization effort will never reach the potential and what it can achieve when you do it in the right way. So the CAR methodology is flexible enough, and it is a generic approach that fits any cloud provider, not necessarily specific one or specific case. So let's start with the knowledge. When managing a cloud operation, there are two sides of the equation. On one side, we have the finance team. They are dealing with the invoices and they are trying to understand what they are paying for. And they basically usually doesn't understand technology. On the other side, we have the tech guys. They are mainly concerned about service availability, technology, and they are less aware of the cost of each service and what they are doing. And in projects we do, we often meet cloud users who are highly knowledgeable with the know-how, with the how-to of using the cloud service, but they lack the knowledge of its pricing model. Or vice versa, a financial analyst, for example, he might be familiar with the pricing model, but lacking the technical knowledge of each service and the service alternatives. So no matter what your role is, you must understand each service and the costs of this service, the pricing model of this service, before start using it or attempting to optimize the cost of this service. So first, you need to understand what you are paying for. Both sides, the tech team and the finance team must understand what they are paying for. They must speak the same language because, again, tech team, they are speaking the tech language, and finance team, they are speaking numbers. And we must find a common language that fits all. Then you need the visibility, you need good visibility of your cost. And on the other hand, you need to be aware of the cost, you need awareness. And in order to take good decisions, you must follow a kind of KPI, because otherwise you don't know how you perform and if you are doing good. And it is always good to get some help from experts, to ask companies, vendors that did that many times and can help you. All in all, this is FinOps. And the FinOps team should bridge between the tech and the finance team, and they should lead the cost optimization effort. Now let's go to the architecture, and we'll start with infrastructure, the infrastructure part, which is usually more obvious, and most of the companies we meet did at least part of it, and they know what we are talking about. Sometimes they don't, but sometimes they know they should, but they don't know how to do that. So first thing, you should use spot instances. You should move your workload to use spot instances wherever it's possible. You can use the EC2 fleet, the built-in tool that AWS provide or other cloud providers has. Or you can use Spot, formerly Spotinst, Elastic Group for that. As you can see in the image, there is very good visibility and you can automate and visualize and manage your application workload, by the way, also stateful workloads, using spot instances, and by that, reduce the cost by up to 90%. For serverless containers, you can use Ocean by Spot in order to achieve the same visibility and cost reduction. Second thing is purchasing savings plans. It sounds simple, but we see that companies struggling on how much to reserve, how much to purchase, what the instance types, and which program to use. It is not a small task, and it is part of the operation flow that we will later discuss. In other cases, where RI reserved instances are more cost-effective, especially when you leverage the RI marketplace, you can automate the RI purchasing by using Eco, for example, by Spot, or other tools. So between the on-demand and reserved and Spot instances, while on-demand is the maximum price, with reserved instances, you can save 40%, and with Spot instances, you can save 80% and sometimes up to 90%. If you have a tolerant, spot tolerant workload, then you can do, and this is the average we reach in project we do with customers. We reach up to 80% usage of spot instances. There 15% of reserved instances, whether it's savings plans or RI, and the rest 5% are on demand. If your workload is stateful, you can use more reserved instances or savings plans, and usually we get up to 60%. The spot instances 30%, and the rest are on demand around 10%. And this is the average we see in projects we do with our customers. Next thing is right sizing. You should always check the option to downsize your underutilized EC2, and not just EC2, but also RDS instances. We see many times, in many cases, that although people are aware of the option to downsize their instance types, they are not doing it. And it's, again, looks obvious or straightforward, but sometimes it requires some work to do before you can do the right sizing. Retention policies. On the storage side, you should move cold or unused data from the standard S3 tier to a less expensive one. You can leverage the intelligent tiers for that purpose, the relatively new intelligent tiers, and or build a retention policy for that. And in this example, we can see over time that if we do manual work to delete files, we succeed to reduce the cost, but right after that, the cost starts increasing again. And in this example, real world example in a company that we did, we see on April, we enabled retention policies where we migrated call data, which wasn't accessed for 30 days to the standard in frequent access tier. And then over time, after 90 days, it went to Glacier. And we see that over time, the usage still, the data still increasing, but the cost is quite stable. Of course, you should always delete unused EBS volumes and snapshots. And this is always a case. Again, people are aware of that, but they tend to forget. So you might put measures in place and automation around that to make sure that unused volumes are being deleted automatically, and you are not counting on your memory to clear these volumes and snapshots. In case that it is possible, you should consider using single availability zone again in AWS term. If your application or specific resource do not require high availability, then you can use the single availability zone and save the inter availability zone cost. And of course, use scheduling. You should shut down test environments at night and auto-scale the other environments. As you probably know, the working hours are only 30% of the entire week. So if you shut down your instances during non-working hours, you will save up to 70% of the cost, and this is significant. Now let's go to the application part, which is more interesting in my opinion. Basically, there are endless ways to optimize your application, and it actually depends on your application, your specific application, and the specific use case, industry, or the type of application you have. I'll show here a few examples, real-world examples from projects we recently did with our customers. There will be a few examples here, but as I said, there are tons of other examples, and each use case has its own example. So let's start with the database. The database, are you sure you're using the most cost-optimized database? Did you ever check your queries to make sure they are optimized? In the data set, when you run in the data center, if you have bad query, it only affects the CPU and the RAM and maybe the performance. But in the cloud, it also costs money and a lot of money. In this image, you can see a real customer that had $20,000 a month for database, for RDS in this case. And together with the customer, we reduced the cost of the database. Actually, we were able to optimize the database usage with a blend of right sizing and query improvement, and we reached 70% reduction in this case. Next is the programming language and environment-specific optimizations. There are specific optimization for the programming language you use, like for Java, for example, you can optimize your garbage collector configuration, and there are other examples for other programming languages. And for the operating system that you use, there might be a big effect on cost. For example, again, real-world example, a customer that had .NET, and by moving from .NET to .NET Core, over time, we see the migration from Windows to Linux. And by the end of this process, we ended up in 30% of cost reduction, mainly for licensing of Windows. Serverless, it is very popular these days to move at least some of the workloads to run serverless or in the edge, but there is a cost for that, and you must know what you are doing in order to not to lose control. One example for serverless. Here, when you run serverless, there is a trade-off between cost and performance when you allocate memory. So as the Lambda pricing model is based on both memory allocation and execution duration, it is recommended to measure the execution duration using different amounts of memory. So while allocating more memory will cost more, it will reduce the execution duration and therefore will reduce costs. Based on this test, you can figure out the preferred configuration for each function, and you can find the right balance between cost and performance. So in order to run this test in AWS, for example, you can use the AWS Lambda power tuning, like you see in the image. It's an open source project. You can find it in GitHub, and it will help you optimize Lambda function in a data-driven way. It actually runs your Lambda function with multiple memory configurations between 128 megabytes to 3 gigabytes. And for each configuration, the tool analyzes the cost of running each function versus the speed of execution. As a summary, the tool will provide a graphical presentation, like you see, showing the most cost-effective configuration versus the configuration with the maximum performance. And again, you can see it in this graphic. There are also some operating system optimization that can be done by automating the kernel configuration to feed the application usage pattern, and the tool actually automatically find out the usage pattern of the specific application and will change the kernel configuration to optimize the configuration. And using this kind of automation, we could reduce, in some cases, the instance cost by 50% and improve the performance of this instance at the same time. This is an amazing thing, by the way. Right sizing, again, in most projects we could find some cases where the chosen instance type for the specific application is not the most effective one. In this example, we made some improvements for the batch job initialization time by changing the prioritization and using priorities in a better way. And this way, we could reduce the cost. And again, same here, we also improve the performance of these scheduled jobs, batch jobs. In other projects we found some tweaks for Kafka and Elasticsearch that reduced the cost, even though it was a company that specialized in these tools. And on top of what they did and reduced, we came up with some innovative ways to reduce the cost even further. The networking part is the networking prices actually is the most complicated one. There are tons of different situations, and there are always ways to improve this area. But before you start, you must understand the pricing model. There was no project where we didn't find some actions to take to reduce the networking cost, which is sometimes a significant one, and we see it case by case. It is always, sometimes people tend to use external APs instead of internal APs. And there are many different, other different examples that I can bring that companies are misusing the networking, sometimes due to lift and shift from data centers. Sometimes it's due to lack of understanding on how the networking works, and sometimes even in companies that have experts in networking, we can find some actions that we could do to reduce this cost. Here you can see an example from the book on how complicated and how different types of pricing there are for the different networking related stuff. Between regions, between availability zone, for each service, for Glacier, for DynamoDB, for CloudFront, and there are tons of different pricing that we have, in this case, in AWS. Now let's move to the second part, the journey towards an optimized cloud. There is no magic here. Optimizing the cloud it's an ongoing task. It's a day-to-day task, and you can't do it once and stop. You have to be on top of that, and we have again the FinOps team or other the CCOE to make sure again you're operating your cloud in a good way. So let's start here. Again, it's only a few examples. There are more, but these are the major ones for operating the cloud to be optimized as much as possible. So a Cloud Center of Excellence, CCOE, it's a function that creates a balance between stability and speed, and it actually keeps the development agility that we tend to do and we aspire to do. CCOE, it's actually a cultural change. When it's successful, the CCOE model, it will create a significant cultural change, cultural shift in the organization. And the purpose here is to bridge across cloud teams to actually be an enabler that remove the blockers to run faster. It also acts as a knowledge center and to empower the team with this knowledge. And it is one of the core fundamentals of for FinOps. The image provides an analogy for this cultural change. Without the CCOE approach on the left hand, IT or the DevOps, they tend to focus on providing control and central responsibility, and they're actually acting like the spotlights at an intersection. When the CCOE is successful on the right hand, the focus is on freedom and delegated responsibilities, which is more like a roundabout at an intersection. And this is the difference between running with and without the CCOE. Account management is about how you manage your multiple accounts, usually. It is about consolidating your account, how you allocate the accounts per team or per group or per product, the naming conventions and the ownership of each account. In order to be effective, you must know the best practices of how to build your organization account or subscription in Azure or projects in GCP. It's basically the same. There are slight differences, but it's basically the same thing, different terms, but managing the account on the right way is a must. Otherwise, you lose control. Next thing is governance. Governance is what you should do in order to avoid losing control on cost. It starts in the identity and the access management, what we call IAM, through governing the configuration and the budget, which allocated to each team. The purpose is to ensure that each user can perform only what they are authorized to do, and that there is no manual work involved with spinning up resources to make sure everything is running automatically, and that all resources will comply with the governing policies that we defined. It's basically the way you control your cloud operation. Tagging or labeling in GCP, it's one of the most important things in the cloud operation. It will help you to label and categorize each resource, each and every resource, and later on to identify these resources when you analyze your cloud spend. It's again a core thing on operating a successful cloud and cost optimized cloud. If you are not tagging your resources, you will never be able to run a lean workload. Now, in order to control and keep control your cost, you must have good observability on your environment. you must be alerted when anomaly happens, when someone did something that he should not do, or when he do something he's not allowed to do. You can use the built-in tools that the cloud providers provide, but you better use an external tool that will give you much better capabilities, like in this case, Cloud Analyzer by Spot, as you can see in the image here. It will give you alerts, it will find the anomalies for you, and this way you will have much better control on the cloud operation. Next, and actually the last point here, is the KPIs. In order to track the cost effectiveness and to make sure you keep your cloud optimized, you have to build a set of KPIs that will reflect both the infrastructure and the application cost. This way, you can always know where you stand, the status of your spend, and the level of success of these cost reduction efforts. Now, to summarize what we discussed, first thing, it's the COW methodology. It fits any type of company, regardless the cloud provider or the application you run on it. It is unique, and since it comes with, from an application and business perspective, and not only from the infrastructure one, this was what gave it the uniqueness and the way to success in applying this methodology in your account, in your cloud operation. Second thing, you can save at least 30% of your cloud spend. This is the minimum we could save in all the projects we did. It is guaranteed, and in addition to better manage your cost over time by following the operation best practices. That's how you do that. And last thing, it's the responsibility. It is not only the finance team responsibility to take care of the cost, but it's everyone in the team should take part in this effort and bring value into it. It's everyone's responsibility at home to turn the lights off when they leave the house. And it's every developer's responsibility to make sure he turns the server off when he leaves the office. So tomorrow when you enter your office, think what you can do to help your business to be more efficient.
Thank everybody who attended today. That's the end of our webinar.
Thank you, everyone. Thank you for listening.